Hello and welcome again to our video for DMA 30, section 3.3, where we'll talk about similar triangles. This is a shorter section, so I think we'll be able to condense all this material into just one video. In this video, we're going to cover the different parts of a triangle, look at congruent triangles, then similar triangles, and lastly work on an application problem. Let's start with the different parts of a triangle and how we'll name them. First, we have a triangle here. It's labeled at the vertices or the points A, B, C, and we're going to name this triangle. We'll draw a little triangle A, B, C. It doesn't matter what order the letters are in, but traditionally we're going to list them alphabetically. Next, we're going to name the vertices, or the points of the triangle, where the lines intersect. We just name these with letters. We've got A, B, and C. Reflected here, A, B, and C. Next, we'll talk about the angles of the triangle. The angles are measured here. The angles of a triangle are going to add up to 180 degrees. And we label angles with this little sign for an angle. So we've got angle A, angle B, and lastly angle C. And then the last thing we'll label here are the edges of the triangle, or the sides. So there's one here, that side AB, so A to B, with a little line over it to show that it's an edge. Then we have BC over here. We'll label that BC with a line on top. And last angle, or edge AC on the bottom of this triangle here. So we'll label that AC. And those are all the different parts of this triangle. Now let's look at congruent triangles. Two triangles are congruent if their corresponding angle and edge measurements are equal. And we denote that with this symbol here. It's equal sign with a tilde on top of it. So that means that these two triangles are congruent. That means that all the angles are going to, measurements are going to be the same. There'll be a corresponding one. And all the edge lengths will be equal. So let's talk about how we read this. The first letter of the first triangle is A, and the first letter of the second triangle is D. That means that angle A corresponds to angle D. B is the middle letter, and E is the middle letter on the second triangle, so B and E will correspond to each other. And then lastly, C is listed last, and F is listed last. So F and C will be equal angle measurements as well. The sides are also going to be equal, so the side AB is going to be equal to DE. AC will correspond to DF, and BC will correspond to EF. So those measurements of all those angles and all those sides are going to be equal to one another. We can write that. Let's annotate that here. Let's start with the angles. We're going to say that angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Now for the sides, AB is congruent to DE. AC is congruent to DF. And BC is congruent to the edge EF. So we've labeled all the congruent angle measurements and the congruent edge lengths. Let's look at an example. Here the triangle XYZ is congruent to, see we've got the equal sign with the tilde. That notation is really important. XYZ is congruent to triangle PQR. So excuse my typo here. We want to name the 6 congruent corresponding parts of these triangles. So all the angles and all the edges. So angle X here is going to be congruent to what? Well, X is listed first. The first letter is going to be P. So that's congruent to angle P. Angle Y is congruent to angle Q. And lastly, angle Z is congruent to angle R. Let's do the edges next. We'll start with the what's almost a hypotenuse of these triangles, or the long side. XZ will be congruent to PR. The bottoms, XY, is congruent to PQ. And then lastly, YZ is congruent to QR. Now we need to find the measurement of angle P. Okay, this M here means measurement. So we need to find the measurement of angle P. Well, since we know that for congruent triangles, the angles are going to be equal, that means P is going to be the equal to the measurement of angle X over here, which is labeled as 27 degrees. Okay, now we need to find the measurement of XZ. This side we know corresponds to PR over here, and since these are congruent, it looks like this is going to be 11 inches. Okay, so to review, all the angles are going to be corresponding or equal, and corresponding edge lengths are equal as well. Now let's talk about similar triangles. If two triangles are similar, their vertices can be matched so that corresponding angles are congruent. So here, A and D will be congruent or equal, B and E will be congruent, so their angles are equal, and C and F are equal angles as well. The lengths of the corresponding signs are proportional. So AB is going to be proportional to DE. BC will be proportional to EF. And AC will be proportional to DF. Okay? And notice the notation here. We use the tilde for similar triangles, no equal sign. That means that's because the angles are not equal, or the side lengths are not equal. We can see that the left triangle is a bit bigger than the right triangle over here. So we say that they're similar but not congruent because they're different sizes. Now let's look at an example. Here triangle DEF is similar to GHI, and we need to find the side lengths for X and Y. And since we know that corresponding sides are proportional, we can solve these with proportions. Let's start with X. Okay, so we need a proportion, so let's find these two equal fractions over here. The left fraction is going to come from the left triangle, okay, and the right fraction is going to come from the right triangle over here. And we want to make sure that corresponding sides line up across the top and the bottom. So let's start with the right triangle. X is what we want to find, so we'll label X on the right. What side does that correspond to? Well, X is going to correspond to this side that's labeled 4.5. So we can plug that in across from it. Okay, and then we need to find two known sides for these bottom two. Remember, we can't really solve for two variables at this point yet. We'll do that later on in algebra. But when we just have one equation, we can only solve for one variable. So we're not going to choose 15 and y, because then we'd have 15 and y and introduce a second variable into this that we can't solve for. So we're going to pick two corresponding similar sides that have known values for, so the 18 and the 13.5 over here. So 18 is on the left triangle, the 13.5 is on the right triangle, and we're good to go. We've got a proportion set up, corresponding sides line up across, left triangle sides here, right triangle sides here. Now we can start solving. We're going to start by taking the cross products of these two. So first here, 13.5 times x equals the other cross product, 18 times 4.5 is going to be 81. To finish solving, we're going to divide both sides by the 13.5. And when we do that, we get 6. X equals, over here, 6. Okay, so we can say that this side over here is 6. Make sure you copy this down. I'm going to erase this now, so we have room down here at the bottom to solve for y. So I'm going to go ahead and erase all this now. Okay, so now we have room to solve for y. Let's start with our two fractions over here. Y is on the left triangle, so we'll label that over here. And it's going to correspond to this side over here, which is 15. Okay, then we pick again two known sides. Let's use the 6 that we solved for x, and its corresponding side is going to be the 4.5. Okay, so I chose this one on the left and lining it up with this one on the right. Now, time to find the cross products. Here we're going to have 6y equals 15 times 4.5, which is 67.5. Okay, we'll divide both sides by 6. Cancel out here to get y. And then 67.5 divided by 6 is going to be 11.25. So by using proportions, we're able to find both the missing lengths for these triangles. X was 6 and y was 11.25. Now let's look at an application problem. This is a common application type for similar triangles where we compare the heights of two different objects to the shadows that they cast. Since the sun is hitting both of these, this man over here and this tree at the same angle, they're going to cast shadow lengths that are similar. So we want to find the height of the tree over here. Let's label this H. Alright? And since the shadows are going to be cast into similar triangles, we can use proportions to solve for these. So let's set that up. Two fractions. This one on the left is going to be the man, and this one on the right is going to be the tree. And we'll make sure that corresponding sides match up. So the man is 6 feet tall, okay, and that's going to correspond to the unknown height of the tree, H. Now his shadow that he casts is 4 feet long, and that should correspond to the shadow of the tree, which is 24 feet long. Now we can find the cross products. 4 times H is going to be equal to 6 times 24, which is 144. Now to finish, we're going to divide both sides by 4. 4 divided by 4 cancels out, and we're left with H equals 144 divided by 4 is going to be 36 feet. So this tree is going to be 36 feet tall, and we knew that because the shadow cast by the man is going to be similar to the shadow cast by the tree. So to review for section 3.3, we covered the different parts of the triangle, the vertices, the angles, and the sides. We talked about congruent triangles, where the angle lengths are equal and the side lengths are equal. Similar triangles, where the angles are equal but the sides are proportional to one another, and then wrapped up with an application problem. Stay tuned for next time. When we cover 4.4, we're going to start talking about the American or the English system of measurement.